the PSS section, okay, which is our official reason for why the textbook could have a 7th edition. Okay, that's why. Yeah, feel free. I'm just going to pause the video because and now we'll go ahead and start again. Okay. Are you sure this is quick? It's quite all right. So the next quick question: in lab, we had the measurements lab. Did anybody watch the play posit on that? Okay, cool. So like 2 people. Remember how we had the sigfig rules? Yes. That's what we're talking about today. Okay. So now for the rest of the semester, we have to follow sigfigs. Yippee! Okay. So measurements. This is kind of important in science, and this is what drives virtually all of our sigfigs, is the concept of measurements. Outside of a lab class, you probably took measurements and just added infinite amounts of significant digits and just assumed everything worked out. We can't do that. You can't make assumptions about your science anymore. We have to be precise in how we run things. So a measurement is a number and a unit. Okay, and we're going to keep coming back to that. Okay, most people specify the number. Okay, at the same time, most people lose the unit. Okay, a number is meaningless unless you have a unit. Okay, and I would actually argue that I need to go back and edit this slide because it's not just a unit. We have the measurement unit and we have a substance unit. Okay. For lack of a better description, unit 2, okay, the one we're in, the substance unit isn't as important. Okay, and so we tend to kind of ignore it. As soon as we get into the next section of material after spring break, that substance unit becomes incredibly important and you can't get rid of it. So this means every time you write down a number, you have a measurement unit and a substance unit attached to it. If you get rid of any one of those pieces, you lose all of the meaning. Okay, all of it. Okay, for instance, 12. What am I talking about? No idea. 12 inches.
What is it on?
The length of my nose. Okay? We've added a little bit more meaning behind that, and we now even get people being like, no, that's not true. Okay? You can now challenge the value of that information. Okay? So you have to have it all put together for you to actually make any judgments or decisions about those measurements. Okay? When we look at our measurements, they break down into 4 major classifications: distance and length, mass or weight, volume and time. We'll use distance and length interchangeably. It doesn't really matter. Okay? Length is usually a shorter measurement. Distance tends to be longer. Mass and weight are not the same thing, but as you can tell, even our periodic table doesn't use it appropriately. Okay? So I will interchange back and forth between mass and weight. I apologize to any future physicists. Okay? Volume and then time. Within those, we run into some interesting concepts. Length. What is a measurement for length? Inches, meter, yard, mile, feet, centimeters. Okay? We have a whole bunch of different measurement units that we could use, which means what are we going to be responsible for doing? Knowing how to convert between them. Okay? So we're going to have to deal with conversion systems within these, and we have to understand how to manipulate those. Okay? Within all of those systems, we're going to deal primarily with the metric system. Don't stress a whole lot about it. Mass measurements, we use balances. We've got a digital balance that gives us all our information on it. I'm going to say there's a cool YouTube video. You should go check it out. Okay? But unfortunately, we're behind enough in class as it is that I'm not going to go to it. But it's kind of cool. A guy gets excited about a silicon ball. Like really excited about it. Okay, so it's kind of neat. You should check it out. Volume measurements. Why do we have volume instead of just using mass? Well, mass is good for solids. Not so good for liquids, because liquids would need a secondary container to hold them. They would just kind of flow over the edge of our balances. Okay? They could also ruin our balances. So we invent an entirely different measurement system for liquids so that we can measure them more appropriately. And that's where we get our syringes, graduated cylinders, and fun stuff like that, okay, which you will see in the lab. If we take a look at measurements, let's take a look at our distance one. Okay, what is the length of that silver rod? 4-point-something centimeters, which is a good observation, and I would argue you can do better. 4.2. So we heard a couple 4.2s. Does anybody want to suggest anything else?
4.3.
4.3. Should we pick on Greg?
Yes.
How long do you think it is, Greg?
4.25.
Okay, and because you guys all watch this in lab and pay attention to it in lab, thank you, Greg. Sorry, didn't mean to kick your table. We can all make fun of, point and laugh at Greg because his measurement is wrong. Why is his measurement wrong?
Because digit plus one gets digit.
Okay. When we deal with our measurements, okay, particularly the analog measurements, so digital balances and digital scales and all that are great and fantastic because they do all of the work for us. We don't have to deal with anything. Okay, somebody programmed it in. But rulers, we have to actually interpret and read. So we have to learn to read them. Okay, if we look at all of our measurements, nobody said 5 or 3. Okay, so that ones place was effectively a truth. Okay, we are always going to be correct there. Okay, if we move to the next place, what have we noticed? Okay, there's a little bit of variance there. That is a guess. Okay, so when we report a measurement, we have to report all of the absolute truth decimal places, and then we get 1 decimal place as a guess. Okay, we do not get more than 1, which means when we take a look at Greg's number, thank you, Greg, we have truth, a guess, and then his 5 is guessing on a guess. That is also known as complete blind luck. You're making stuff up. Okay? We're not allowed to make stuff up. We're allowed to have an educated guess, 1, but that's it. After that, you're guessing on guesses. That doesn't work. What if I want more information? What if I want that 5 to be true?
You better know the second number.
How do I know the second number?
You can use a different measuring device that has...
I need a different measuring device. And now bringing in a different measuring device, if I look at that same silver rod, 4.1, 2, 3, 4, 5, 6, 7, 8, 9. We're being marked off by tenths. We can say that is 4.2. Those are now all truth values. We get 1 guess. Greg's guess of 5 could now be valid. Could 3 also be valid? Could this be 4.23?
Yes.
Yes. Okay, it is literally just a guess. Okay, as close of a guess as you can make, but it's still just a guess. Okay, kind of makes sense.
Why would you be able to do 4.3? Because it's 4, you know that it's past the 2, but you can't see that it's past the 3.
4.2.
For this one,
Yeah.
so I was saying 4.23.
Oh, okay.
Thanks for the clarifying. Yeah, 4.23. Yep, you're good. Okay. So that's how we have to make our readings. That's how we have to take our measurements. Officially, 4.23 is also wrong. Why is that wrong?
What's your guess number 3?
No, with that second ruler, 4.23 should be fine, shouldn't it? As a number? That was a hint. Okay, we can rewrite it up here. 4.23. Why is that wrong?
Because you don't have the unit of measurement.
What was the unit of measurement?
Centimeters.
Centimeters. Now it becomes correct. Okay? Everybody's being like, wow, that is really nitpicky. That is how nitpicky we have to be. We have to be very precise in our language when we're dealing with our measurements because a subtle change in the unit, okay, you may think it's implied, somebody else may not. Okay, so you have to specify that information. Make sense? Question? You sure? Okay. Are you pacing just for the sake of pacing, Greg?
Yeah.
Okay, just checking. Okay, so significant digits. Okay, once we've got our measurements, we now have to evaluate this concept of significant digits. Okay, that's the whole point of sigfigs, is it comes naturally from measurements. So if we go through and take a look at those digits, or those numbers, we should be able to specify how many significant digits are there. Okay, because we've had a little bit of practice of it. You guys should be awesome at this. So we'll start. On 3, we'll just start listing off the numbers of sig figs in each of these, starting from left to right. Make sense? Okay, 1, 2, 3.
2.
Next. Next. Next.
2. 1.
Okay. I had to put a line through that first one because I screwed up. It's not 2. It's 1. Okay.
Because there's nothing.
Why?
There's nothing.
Okay. When we go through and look at our digits, the numbers 1 through 9 are always significant. The problem comes in with zeros. 0 holds 2 different meanings. 0 holds the meaning of not the number 1 through 9. It also holds the meaning of don't put a number 1 through 9 here. Okay? In one case, it's saying it is nothing. In another case, it's saying don't put anything here. Those seem like very subtle differences, but they have massive meaning differences. Okay? So we have placeholder and we have value. Okay? And that first number, that 0, is acting as a placeholder. It is telling me to not place the 1 in the 1's place. Because if I did that, this number becomes 1 versus 10. It's kind of a big deal. Those of you think, oh, that's not that big a deal. Your hourly wage. Okay? That's going to make a pretty significant difference. Okay? If we move to the next number, that 0 now actually holds meaning. That 0 is actually saying don't, or the number here is not 1 through 9. Okay? That 0 holds a different value. Okay? The only thing different between these is the placement of that decimal point. And thank you for asking that. Aren't these the same numbers? No.
Because it has a decimal point.
Okay? This number right here is
10.0.
10. And we can actually try and write this out. We'll use the English language. It is 10. This number right here,
Unknown.
What?
what? That 0 is a placeholder. I don't know what that actually means. All I know is the end result is I get something in the ballpark of the number 10. Okay? Why not lower than 5?
Because is it lower than 5?
Okay, well, why not say lower than 7? Why did I pick 5? What happens if I drop to 4? Is that number closer to 10 or closer to 0? Closer to 0. 5, depending on our rounding rules, would round up to 10. Why not 15?
Because if you go to 15, it'll round to 20.
15 would round up to 20. So this first value here is literally the number between 5 and 14. And really, the is probably the improper article. I think that's right. It should be a number between 5 and 14. Okay? And again, we might think that's silly and weird and, oh, well, that's dumb. Okay? It's only dumb because the human mind can comprehend numbers around 10. But when we move up to larger numbers, the meaning has to still hold. We can't change the rules as we move to different scales of numbers. Okay? And it all comes from how we're making our measurement. Okay? Kind of makes sense? Okay, Greg wants to add something about morphemes, and I only kind of get it, so I'm going to let him do it.
A morpheme is the smallest unit of a language that changes the meaning of something.
Oh, yeah.
So a single decimal point is a morpheme. It's literally the smallest thing you could do is a dot. So in this case, it's changing the meaning and determining what's significant and what's not.
Okay, so what we need to know is how do we identify those zeros, one being placeholder versus one holding value. That's our sig fig rules. Okay, so when you go through and look at significant digit rules in your textbook, they come up with a list of like 5 rules. You check the tutoring center, 5 rules. Check your lab manual, I think the lab manual even says 5 rules. Okay, and it is ludicrously dumb and overwhelming. There's 3 rules. Number 1, sig figs 1 through 9, or digits 1 through 9 are always significant. The next part comes down to deciding that 0, and that's it. All of the rules that you see are deciding what's going on with 0. Okay, if there's a decimal point, then the 0 has to be controlled. Okay, or sorry, no decimal point. The 0 has to be controlled. So we look to the left and right. Okay, is there a significant digit to any place to the left and right? If there is, those zeros are controlled zeros. They actually hold value, so they are now significant. Okay. If there is a decimal point, then the 0 needs to be immediately preceded by a significant digit to be significant. Okay. So we've got the rules. You've had a little bit of practice. I'll give you a minute. Identify all of those. So now's as good a time as any to remind you that the lecture slides are posted on Canvas. For those of you frantically writing down the rules, you don't have to frantically write down the rules because you already have the rules written down for you. All you have to do is have the slides. Okay? If it's a question of memorization, the memorization of the words isn't important, so the muscle memory behind writing out the rules, not useful. What would be useful? Practice using the rules. You mean exactly what I asked you to do, and instead you wrote down all the rules? Yeah. Okay? Think about the actions you're doing. Are they valuable? Okay? Rules themselves do need to be memorized. You're going to memorize them through usage because the string of the words isn't going to be helpful. All right? So, upper left-hand corner, we start there. We have 3. Next.
3.
Next.
4.
Upper right.
2. 3.
Next.
3. 2.
Next.
2.
Next. Okay, I've got 3 circled. Those 3 I want to talk about. Does anybody want me to talk about any of the others? Yes, Haley, which one?
Why wouldn't the second column, the third one, why wouldn't that be 3?
We'll talk about it. Anybody else? Okay, go ahead and start with the, because in theory students are more important than me, so we'll start with Haley's question. Okay, how do we count our sig figs? Right, so my recommendation is you should go through and underline your sig figs. 1 and 2 guaranteed are significant. Okay, if there is a decimal point, what do I have to do? So I'd move to what I've listed here as rule 3. We need to have a significant digit to the left. That's what preceded means. Is there a significant digit to the left of that 0? No, which means the 0 is? Insignificant is a fancy word. I would prefer not significant, but I understand where you're going with that. How about the next 0? What's to the left of it?
0.
I would argue not 0.
Not a 0.
Oh, it doesn't.
Not a significant value, which means not significant. How many sig figs?
2. That just doesn't make
2.
sense to me though, because like it feels like it is significant because if there wasn't a 0 there, then it would change the.
True. Does the 0 not have meaning? No, the 0 absolutely has meaning. What does that 0 mean?
That you are now in the...
Don't place the 1 in the 10th place. So it's still holding meaning, but that meaning is not a numerical value. It is a placeholder value. Right? And that becomes the issue with sig figs and zeros, is trying to differentiate what that meaning is. If it is a numerical meaning, it's a significant digit. Okay? If it's a placeholder meaning, it's not a significant digit. Okay? The other way that we could go through and write numbers would be to make sure we have a number line written out underneath. So that if I put a 1 into my number line and the meaning is 1, I know it's just a 1 because it's in the 1's place. Okay? Whereas if I changed it and put it here, it's still a 1, but now the meaning is different. What is the meaning?
It's in the 10th place.
It's a 10th. Okay? So with a number line, I could see that meaning. Okay? And if I wrote something like this, I know that 0 is now holding meaning because I've written it there. Okay? Whereas if I did that, the 0 isn't holding meaning. What number belongs in there? Well, I don't know. That's why I didn't write anything. Okay? The problem with that is then when do you need to use a number line? When you have a number. And when we take measurements, what are we getting? A number. Which means when would you use a number line? All the time. Which would mean we need to have all of those places marked out. Well, that's okay because the largest number is?
That we have up there right now.
What is the largest number?
The one with the has the 4, the one that you say is wrong.
9?
The largest number is 9?
Are you saying
Right,
is
for-
that what you're asking?
What is our largest number? It's infinite. It's infinitely large. Which means for me to go through and write number lines for every single measurement, I'm not done because I haven't specified all of the placeholders. Right? I don't want to write a number line every single time. Right? Because the first person to do that still hasn't finished. Right? So we invented a new system that allowed us to not have to write decimal places each and every single time. That new system, unfortunately, meant using 0. The problem with 0 is it holds meaning, a numerical value, as well as a placeholder value. Okay? What could we have done instead? Could have invented a new symbol to represent a placeholder. We didn't. Sucks for us. We're dealing with zeros. Okay? So we have to know that meaning. Okay? So let's take a look at the bottom left, because we had a couple people shout out different answers. Okay? The 1 and the 2 were significant. We take a look at the first 0. What is immediately to the left of it? A significant digit, which means the 0 is significant. We move to the next 0. What's immediately in front of it?
A decimal.
What did I just point to? Okay, and we'll hear people saying zeros. No. For the first one, I didn't say we were pointing at a 2. What did I say we were pointing at? A significant digit. Is that 0 significant?
Yes.
Yes. So we look to the blue one. What's immediately to the left of it? A significant digit, which means the 0 is significant. How many sig figs? 4.
Oh my goodness.
Okay? So stop using a numerical system and saying, oh, it's a 1, it's a 2, it's a 0. It's not. It's a significant digit or it's not. Okay? You have to use that system when dealing with significant digits, because if you don't, you'll start making simple, stupid mistakes. Yes?
So does that mean if you if you had 100,001, would that be?
That's a lot of zeros. Thank
I
you.
know. So
100,001. Okay.
So since the 1 is a significant digit,
Significant.
the 0 would
Significant.
yeah. So the 0 after it would have to be significant. So does that mean the 0 after it would be significant, and then it would keep?
Okay. So if we look at our number, we have to be careful here because we didn't specify a decimal point. Okay. Did you want a decimal point or not? It's up to you. It doesn't matter. No decimal point. Rule 2. No decimal. And the 0 must be controlled by numbers to the left and to the right.
So it wouldn't, but if there was a decimal point.
At any place. So we look to the left of the first 0. Do I have a significant digit?
Yeah, but the right you don't.
At any place.
Oh, what the? Oh my goodness.
Stop doing this, Mike.
Which is now a significant digit. When you go through and look at every single 0,
Significant.
they're all significant. And our answer comes out as 6 sig figs.
Are we going to have a test on this?
Yes. Okay. And trust me, I'll make it worse here in like 5 seconds.
Don't do it.
Okay.
So you can throw the decimal point, wouldn't it still be 6?
If we throw in the decimal point, it will still be
6.
6.
Let's put a 1 after that decimal point. Let's make it 7.
The 1, 0.
Okay. If there is a decimal point, then we just need to be something to the left. So we look at the first 0. What's to the left? Significant digit. Next 0. Significant digit. Next 0.
Significant.
So if
Okay.
you had
So long as you have a
101,000,
number.
then without a decimal point,
Okay, so let's try a new number. Whoops, shouldn't have erased that too much. So 101,000
yeah.
without a decimal point?
Without a decimal.
Without a decimal point. Now how many sig figs?
3. No,
This
wait.
one,
They're still good.
1 and 1, yes. Let's make sure we don't confuse that comma with a 1.
Yeah, there's gonna be 3.
What do you got, Joey?
I mean, 3 visitors.
Why is it 3 significant digits?
Because beyond the last 1,000, there's no significance to the right, so those zeros are
Right. So you've jumped to this one and said to the left of that 0 is a significant digit. What's to the right of it? No significant digits, which means
They're all nonsense.
not significant. I'm going to open that up in just a second. The first 0 to the left and to the right, both significant, which means
Significant.
significant. We get 3 sig figs. Huh?
Yeah.
It's not, I mean, it isn't that bad. You just got to use the rules.
You're gonna put a decimal point in there now, aren't you?
Of course.
You can't be nice to us for 5 minutes.
This is being nice to you because you're finding the opportunities to get things wrong now instead of on the exam. This is actually insanely nice to you. Okay? Decimal point. Now what?
1.
They're all
The 1 is significant. The 1 is significant. Because I have a decimal point, the 0 needs to be preceded by a significant digit to be significant. What is to the left of the first 0?
significant.
A significant digit, which means
It is significant.
that is significant. We look to the left of the next 0.
Significant.
We look to the next 0.
I can't even say the word anymore.
I'm making you say it a lot, I know. Which means 6. Okay? For those of you not going in to say something like engineering, you might get away with calling this stupid. For those of you moving into engineering or science, significant digits are insanely important. Okay? It is the reason between life and death. Believe it or not, we have had shuttles explode, space shuttles explode because someone didn't pay attention to the significant digits in their measurement. Yeah, you'd think, how could someone screw that up so thoroughly? All it comes back to is they didn't record the significant digits appropriately, miscalculated something, which meant they measured something, which then meant fuel leaked out when it wasn't supposed to leak out, and the whole thing goes up. Yes.
And even if you're not going into the sciences, if you're going into business at all, if you're going where
Yeah.
you might ever talk to an engineer or a scientist, you need to understand this as a language, even if you are more of a humanities-based person. You need to understand this as a language and the values behind how this communication works.
I'm just not going to graduate then.
I mean, that's on you, bro.
That's rough.
Oh.
You got it.
Criminal justice, you'll probably encounter cases, law courts or law cases about significant digits. So it could absolutely show up. It is an important thing to make, and believe it or not, important observation, it's something that we should be making every day, okay, with every measurement we've ever made. Okay? This is why when you fill up the gas, do they report just the 2 decimal places?
They go out to 3.
They go out to 3. Why? They can charge you more for it. They've now provided more accuracy behind it. They can round up to that last cent. If they don't provide that value, they can't round up to that. and they end up having to undercharge. Okay? So they add more information there so that they can charge more appropriately to the cylinder or to your gas tank. If we take a look at the next two measurements, okay? I circled them both. You got them both right. What's the difference between those two? Okay. If we go through and look at it, really all it is that we didn't use that 0. Okay. Does that 0 change any of the meaning?
Yes.
No, it's still the same thing. It's
It's
just
the exact same number. So why do I care about that 0?
you don't.
It's a placeholder
Okay.
to top put a digit there.
I tested this with the new iPad pen that I've got. It doesn't work quite as well because the iPad's more sensitive. But most of us work with pens or pencils, right? Okay. When you make a decimal point, what do? Okay. See, that shows up. See, that's the problem. If we just make a dot, that becomes kind of hard to read. So if I went through and did something, like this, what number have I written?
12.
12. Really?
Now there's the decimal.
There's a decimal point there. That's not 12. Okay? Your calculation just went from a decimal value to 2 orders of magnitude larger. Okay? That's a pretty big mistake. So why include the 0? How many of you have written a 0 in front of a 10 value?
Yes.
Never. So why on earth would I write 0, 12? That doesn't make any sense. Oh, I actually have a decimal point. That 0 is there only to provide you enough pause to be like, I actually meant a decimal point there. That's why you include it. It's known as a leading 0. You don't have to include it because it doesn't change significant digits. It doesn't really even change meaning. It just draws attention to your manual calculation. It's a technological advancement in understanding how we run our calculations or limitation.
Would that 0 be for other people or yourself?
Both, but primarily for you.
Okay.
Okay. Because if somebody else was using your work to make calculations, they're going to want to know that that's
Yeah.
The writing answer is whoever
12
the reader
tenths.
is, then you can be the reader of your own work.
yeah.
Okay.
Okay. On a multiple choice test, it's multiple choice.
Right.
It's really going to be for you because it's multiple choice. If you circle the wrong answer, I don't really care, but you will.
You talk to me and then give me the point anyways. Just kidding.
And so
Yes.
is that why my teacher in high school always put a 0 before any decimal?
It's probably why.
Okay.
Yep. It's only there to kind of emphasize that decimal point, and that's it. Okay? So since we now know sig figs,
No.
how many quarters in that picture?
So
Yeah, it's
Yeah, I keep waiting for someone to call me out on that. How many sig figs in 7 quarters?
Stop it. Stop it now.
How many sig figs in that measurement?
2.
Okay, what are the significant digits that are getting you 2?
7.00. if you
Does it say 7.00?
oh, just a 7.
No, it just says 7. So I asked, how many significant digits in that measurement?
1.
1. So you're saying that that image could potentially have 7.1 quarters.
No.
It could.
Well, but if you say only one significant digit,
Oh,
then 7.1 is an equally valid answer to write.
Because it's your one guess. You wanted to guess.
So when you look at a stack of 7 quarters, you're like, my one digit guess. That's possible. There is a 1/10 of a quarter sitting in here. No, absolutely not. If you got 7 quarters, there's 7 quarters. Okay? I know it's exactly 7, right? 7.0. So you're saying 7.09 quarters was possible?
0.
Oh, another 0. 7.007 quarters? Put another 0. Put another 0. How many zeros are we going to have to string in here?
Too many.
An infinite
Close.
number.
An infinite number, which means how many significant digits in this measurement?
Infinite.
Infinite.
Because all the zeros are significant.
All of those zeros become significant. So there are some measurements that are exact measurements. They will have infinite significant digits. Okay? When we think about the calculations that we run in our everyday life, those calculations, we've assumed infinite significant digits. And in some cases, we're correct. A lot of cases we aren't, but in some cases we're correct, and we just kind of deal with the wash. Okay? So when you go through to calculate how long it's going to take you to drive from here to Disneyland, you don't really care if you're off by 5 minutes. Okay? Or if you're off by, say, 5 feet. But in a space shuttle launch that's off by 5 feet, that's a pretty big deal. Okay? So depending on the system that we're working in, we have to be a little bit more careful with the tolerances of our measurements. Yes?
So if there's an infinite number of sigfigs, won't that apply to like every number?
That doesn't apply to every number. That applies to every counting measurement.
Okay.
And only counting?
1 through 9.
Okay. Why 1 through 9?
Because
And I would argue actually 1 through 10, but yes.
there's a 0.
I would argue even counting to 10, I can guarantee that I'm right at 10.
Well, you can be right here, teacher.
10 fingers. When we count, we're usually pretty good at counting relatively small numbers, like 1 through 10, because we have 10 fingers and toes. If someone chops off your finger, you now lose precision in your measurements, and you can now only count to 9. Okay? And for those people that think that is absolutely ludicrously silly, we literally have a problem within our brain where we cannot comprehend numbers larger than 10.
Why?
That's rough.
When you go to the store, how many eggs do you buy?
12. A number.
Do you actually say, I'm going to go to the store and buy 12 eggs?
It doesn't.
What is a dozen?
12.
12. We have such a problem with numbers greater than 10, we invented a new digit or a new symbol to represent 2 numbers higher than 10.
Well, if you're going off that, then isn't...
Okay?
No, that's 13.
And a baker's dozen is still larger. Okay? So we have a hard time with counting. So counting measurements can sometimes hold infinite sig figs. It becomes a little bit of a gray area, but where it becomes more important are exact definitions. How many inches are in 1 foot?
12.
12 inches are in 1 foot. I know that's, make those O's. Okay? How many sig figs?
A number.
2?
1.
For 12? If we're talking
12?
the exact.
Well, that exact statement right there. 12 inches and 1 foot. How many sig figs?
3.
Okay, so I heard a 12 because there's 1 and 2, right? But isn't there another number with the 1 there?
3.
Is it infinite?
Okay, are those numbers all tied to each other?
No.
No, so I can't call it 3.
2.
Infinite?
It's infinite. Why is it infinite?
Because you can add.
Can you say you have 12.01
No.
inches in a foot?
It's 12 point.
It's 12 point
And then
an infinite amount of zeros in 1 point an infinite amount of zeros. Okay? Why is that true? Do you actually have to write an infinite amount of zeros? No. What you do have to recognize is that that is an exact definition, which means, as an exact definition, how many sig figs does it have? Infinite amounts. Okay? So we have to acknowledge that definitions have infinite sig figs. Where this gets fun is sometimes definitions aren't infinite.
Where there's a point.
Okay?
You broke it, it's already stop.
So we will see that, probably not today. Okay, but we will have to worry about that in some cases. Okay, so we got a flurry of hands. So we'll go Madison. Krista, are you done with your question? Or do you still have it too?
God.
Okay. Madison.
Couldn't we also put, like, if they have 1 sig fig, can we also just put 1 and then, like, the infinity sign after that?
But why?
Because the infinity
So-
sign for an infinity number of zeros.
So you're right. We could go through and say 1 infinite. Couldn't I also just say 1 and remember that the definition of that is an infinite number of sig figs? So you're saying, can I add more work? Yes, you can add more work. Haley.
If you have 1/3 of something, would that be considered? I mean, it would still be infinite, but it would be. I don't No, I'm perfect.
So, and I know what you're trying to do. What you're trying to do is take the measurements that we've dealt with in our everyday life and trying to apply them and match them to this exact versus measurement, right, or sigfigs. And that's where you're going to potentially run into issues, because most of what you have done is assumed infinite sigfigs in those calculations. That wasn't technically correct, okay? If you've gotten into baking enough, okay, you might notice that recipes don't say cups of flour. Okay, some people are saying, yeah, you've seen that? Yeah, they don't say cups of flour anymore. Why? It's not very precise, because when you take a scoop of flour, okay, are you packing it? Are you not packing it? How much air is there? That's all going to change the amount of flour you put in, which can drastically change the end result of your baking product. Okay? And some people are actually nodding their head, yes, actually going, yes, this actually makes a difference. I've never experienced it, so I don't know. I just heard about it. Okay? So it can make a really big deal. So that's why you go by mass. Okay? You can provide more precision in that measurement to get the accurate value that gets reliable results. Sigfigs. That's ultimately where it's coming from. And that's that third measurement, if you think about it, third a cup of something. Okay? And so depending on what you're doing, it doesn't matter. In baking, sometimes it matters. So we scale to a system that actually incorporates sigfigs. Okay? Maybe you don't care. You're just making the cake from the bag. Who cares? We throw it in and it's okay. Okay? Using a large egg versus an extra large egg wasn't a big deal. Okay? I still ended up with a cake. Okay? Kind of makes sense?
What if you put a decimal after the 2? So it'll be 12 point. Would it still be infinity?
If I now go through and put 12 point inches in 1 foot, and I'm just going to do equals 1 foot, we've actually changed the meaning of our statement.
Yeah.
One.
Yeah, 1 point.
You've actually shifted outside of the definition. Okay, which sounds kind of weird. But what you've done is said, I don't accept 12 inches in 1 foot. I'm creating a new system that is less precise. How many of you actually want to go through and change the current measurement system? Probably not a good idea. Okay, why?
Too much effort.
What was an inch based off of?
12. Wait, an inch?
An inch. What is an inch?
7 meters?
That's one option. It's the history of an inch.
Wasn't it like finger length?
It was the finger length. I believe it's the first knuckle of the king. What happens when the king dies?
Changes.
You get a new king, which means a new inch. Okay? Imagine we did this with weights. Okay? A pound of gold is worth something, and we say a pound is now based off the weight of the king. When the king changes or dies, our value changes. Everything changes, which means with our definitions and our measurements, we do not want to change them. We want them to be exact, and we want to keep them as simple and concise as possible. The more variance we put in, the more we screw ourselves over every time that measurement changes. This is why when we look at the measurements for both metric and English units, there is a location that is under lock and seal, barometrically pressurized, temperature controlled, under locked security guards, guns blazing, everything, to make sure nobody messes with these. Okay, because if...
That says 12 inches.
Nope, it's an actual stick. It is a stick that they said, this is 1 foot. If someone comes in and messes with that 1 foot, the whole measurement system is screwed over. Okay? Becomes more kind of important with, say, weights, like a single gram or a single pound. They've created something that weighs exactly 1 gram or exactly 1 pound that everything is based off of. If that one thing changes mass, the whole system is messed up, which becomes important if we, I don't know, valued the monetary based, or our monetary system based off of, I don't know, the mass of, say, gold. Oh, we do that. Yes, we do. Sort of. Okay? If we have that value associated with it, everything goes haywire if our mass system changes, because now our currency system changes. Okay? So we have to be consistent behind our measurements. That's the whole point of sig figs. That's the issue with measurements versus exact. Cool. So based off of that debate, I can tell this is only going to get worse.
Oh no.
Why do we care? Okay? So if we go through and do this measurement, okay, we don't. Okay, this is your paycheck versus
Okay, we do.
this is your paycheck. Which one are you going to prefer?
I like the 149, please.
Why?
Both of them.
More money.
More money. But if we don't care about significant digits, we could delete that and you don't get that money. Okay? So we do care about those significant digits. Okay? They hold meaning and we want to keep them. Okay? If we don't, okay, we lose that meaning, we lose that value. So sig figs become exceptionally important. You just haven't realized how important. When we go through to do addition and subtraction, our sig figs can potentially change. So if I asked you to add these two numbers up, okay, I believe I can pull this one off. I learned math a little bit differently. I add left to right. Carry. Yeah. So we would get that number. Is that number correct? If I asked you to add those up and you told me that that was the answer, are you correct?
Robbie, was that right? You looked at
I
the
just saw the 11563.
No. That is not a correct answer because you haven't appropriately taken into significant digits. When you did this calculation, you made a very massive assumption about this. You assumed
Everything beyond it is zeros.
that those were zeros.
You also didn't include the measurement.
Fair enough. Do we know those to be zeros? No.
Assume.
You made an assumption. And what happens when you assume?
We get things wrong.
Makes an
Makes
ass out of
people
you.
die.
There you go. You know your little device. Okay? Does it change the value if we go through and make those nines?
Yeah.
Because just as much as they could be zeros, they could be nines. And if we go through and calculate this one, okay,
No.
the myth has already been removed. I need to write it somewhere else next time.
Good job, Robbie.
If we look at the two numbers that come out of this, what do we get?
That's so funny.
Different numbers. Legitimate. Where do they differ?
We're just writing on his wrist.
Hundreds place are fine. Tens place is the same. Ones place is the same. They differ
At the tenth.
in the tens place. Because they're differing there, that is ultimately the guess. I don't know that meaning there. That is my guess place. Go back and take a look at the measurements. Which of those did I guess soonest with?
Top one.
The top one. Which place did I guess in?
Almost all of them.
Which place did I guess in?
The 10th.
The tenth place. Take a look at my measurements. Where did they differ?
The 10th.
According to our sig fig rules, the result is only as precise as the least precise measurement. The first one is precise only to the tenth place, which means my answer needs to be precise to the tenth place.
So you don't.
Which means the answer I get for doing this addition becomes 115.6 grams. That is now the answer. Okay? I can only report to the tens place. Does that mean I ignore all the other numbers in the other calculations? No, they still get added into this. I still end up with this number up in red, but I can only report out to that tenths location. That's how I do addition and subtraction. Okay? And this is really, really fascinating, at least to me, because if you go through and test this exact same thing happens with all addition and subtraction. The place where you get a little bit of variance, whether they're zeros or nines, happens in that least precise place. Yes?
How did you get 6? Because when you're doing that...
2, 6, 3, 5, and 8 is
Yeah, but when
13, 1,
That's not your question.
carry your 1,
That's not your question.
10, 6.
But if you only care about the tens place.
No. I care about reporting my answer to the tenths place. Does that mean these two numbers did not have meaning there? They did have meaning. I must keep that meaning. I can't delete that meaning. I have information about those places. Those places could potentially affect that guess. That's why I report there. So you have to run your calculation with all the significant digits of every measurement you've ever used. Period. You can't delete that because you have information there. Okay? That's why it comes in as a 6, because the one beforehand, 8 and 5, gets me a carry across. 3 and 7 is 10, plus 5, 15. The one I carried, 16.
So
That's why it goes.
we're gonna assume they're zeros and just figure it out with zeros. Or just,
Yes, you make the assumption that there's zeros in the calculation because we don't know, but we can't report those numbers because we don't know those numbers. Okay? So all we can report is what we do know. We do know up to that tens place, and we know that those other numbers are going to affect it. That's why we have to include them in it, and that's why that goes up to a 6. Which is also ultimately why that 15 goes up to or that 5 goes up to a 5 from a 4. Because I had some information to add to that.
okay, makes sense.
Yes?
So 114.3 is the least significant because it has
It's the least precise.
the least precise because it has the least amount of significant digits.
Does it have the least amount of significant digits?
It doesn't expand.
1, 2, 3, 4, 1, 2, 3. So it's not the number of significant digits, it's the precision of it. Okay? How accurate does it get? How many places after the decimal do we report? Or even how many, it's just places in general, because it doesn't have to be after the decimal. Okay? We could have changed this number to be 100. Okay? Now the only place I can represent would be where?
Before the decimal.
The whole number.
If I added this up, what does my answer become? I actually don't know all the math here. 2, 6, 3, said 13, 6, 1, 0, 1, right? What does the answer become?
100. Sorry, 100.
Where's my least precise place?
Whatever place the 1 is,
Whatever place the 1 is. Which one?
the first one. Top.
Yeah, our top one up here. What place is that? The hundreds place, which means I can report to the hundreds place. What's my answer? Your paycheck just went from 100 to 1.
100
Where does that 1 need to be located?
in the hundreds place.
In the hundreds place, your answer becomes 100.
So it didn't change.
Yes. You did the addition and it didn't change. That's not possible. Right? If I rip out one of your hairs and add it to the top of my head, have I changed mass? So when I step on the balance, it's going to tell me I weigh something differently?
Yes.
Probably not. Okay? It all depends on the scale of the numbers that you're using. Okay? We could make the argument, which is a valid one, should I be doing this math?
Not like that.
What do you mean not like that?
I wouldn't do it like that. If it didn't have a decimal, I moved the 1 over by the 7.
You can't slide the 1 over because that 1 means 100. If you slide the 1 over to where that 7 is, you're now making it tenths. That's changing the meaning of the 1.
But then we need to put a decimal and some.
We don't need to put a decimal because if we put a decimal, those zeros become significant.
I think it depends upon what you're trying to figure
Yeah,
out.
it depends on like what the problem is. If you're talking
How many
about-
significant digits are in this first number?
If you're just talking about that, then
1. How many significant digits in the next? And the next one, more than that, 5. Do we really want to be adding numbers of different meanings? No. When will we be asked to do that?
Other problems.
Only in lecture. Only when looking at significant digits to see, do you understand the rule? When you move into the lab, you don't take a measurement like this.
Yeah.
You would make sure that your measurement was the same number all the way through. When you go to measure length, you don't go, well, this one's approximately 10 feet and this one's half an inch. You're going to get two different systems that don't mesh well. You measure to the same systems, okay? So that you can get that consistent accuracy. We bring it up here so that you recognize the power behind that. You've already started to do that on your own. We're now saying, are you aware that you've done this? Okay? And are you aware of the repercussions of those actions? Okay? That's it. That's the point of this. Okay? And because we're so excited about this, I can tell already we're going to love the next slide. There are other mathematical operations. Do the rules change? Yes. Okay? Why? The exact same thing happens. If I go through to determine the area of the square, length times width, or length, whatever it is, okay, we calculate that out. At 4.6 to get this answer out of the calculator, I'm assuming there's a 0 there. It could also just as easily be a 9. Look at the two calculations. Where do they vary?
The hundredths.
Hundredths? They do vary in the hundredths. I would argue they vary earlier than that. They vary in the ones place. That's where I'm guessing. Okay? That is my guess value. That doesn't make sense with the measurements that we've taken according to addition and subtraction. Okay? According to addition and subtraction, I should be precise out to the tens place. But if I run the calculation, I can see that I'm guessing a lot earlier than the tens place. How many significant digits in 34? 2. How many significant digits in 7.28? 4.6? What happens to our rule? 2 versus 2. The rule for multiplication and division is now the number of sigfigs. When I multiply and divide things, my answer gets reported to the fewest number of sigfigs from the measurements that went into it. Okay? So now we've got to go through and decide which of these numbers, because we have a 33 and a 34. How do we get the 34?
Because they had 4.69, but it's just 4.69.
We said 4.69 because we said we just guessed. Okay? We don't know that it's a 9, so doing that isn't useful. We start assuming it's a 0. We look at our calculation. 3 sig figs, 2 sig figs. 2 sig figs dictates my answer. My answer becomes 33. Okay. When do we have to worry about sig figs? Not quite always. Whenever we take a measurement, whenever we manipulate that measurement, that's when we need to worry about sig figs. Okay? You guys haven't worried about it yet in your careers, probably because you haven't taken enough science classes. Science finds this insanely important. This can be a difference between life and death. Okay? And it can be a spectacular death. Okay? That everybody sees how horribly you screwed up, like a shuttle explosion. Okay? So science really cares about tracking significant digits, which is why when we move into a science class, we have to track them. Okay? It is important to deal with it. If you choose not to, that is your choice. You can also choose to get a lower score on your exams. That is fine. Okay? The next thing that can come out of this is what happens if we take a look at that addition subtraction. Okay, we add those two numbers up. Where do I report?
To the third place.
To the which place? Tenths is right here, right? I can only report to that.
Not the ones.
Okay, the ones, I can only report out to here.
I don't know.
Hundreds.
The hundred?
The hundredths,
Okay, there.
I didn't hear hundredths.
That's what I said.
Okay, sorry. So I can report out to the hundredths place. So my answer becomes 1.33. Anybody see an issue?
Yeah, there's a 5.
Because you would round.
Should I be rounding or should I not? Okay, so we have to include rounding issues in this as well. The textbook adds a layer that is more precise behind the rounding. I'm not stressed about it. If it's 5 or larger, add 1 to the previous number, which means this is not 1.33, this is 1.34 grams. And we now have the correct result from that addition. Okay, multiplication division. We run through that calculation, 7.8 times 4.68. Calculator spits that number out. How much of that can we keep?
To the tenth?
Okay, so we might reference the place. The place is a phenomenal answer if we did addition and subtraction. We're doing multiplication division, so it's just the number of significant digits. There's 2 sig figs in this first number. There's 3 in this one, which means
The whole number,
36, but
7.
that first insignificant digit is 5 or larger. We'll add 1, 37 units squared. So when we go through and do our calculations, we will also have to worry about rounding as a potential issue. Okay? Ultimately, what you have to do is just use these rules because I find it particularly useful. Come on. I put them all on one slide. So if you take a look at the slideshow number 25, you now have all of the rules for sig figs on a single slide. You need to know these. I will say that more frequently than not, we do multiplication division, which means what does everybody do with the multiplication division rule? You memorize it. You do a really good job of memorizing it. Because we don't do addition and subtraction, what do you do with that rule?
Forget it.
You forget it. So what do we test on?
addition and subtraction.
We test on the addition and subtraction because more than likely what's going to happen, you're going to take the multiplication division rule and use it incorrectly in addition and subtraction. Watch out for that. Okay? I can only be so subtle. Questions? You want to practice it? Yeah. There you go. So, as far as speed goes, we're going a little bit faster than you guys should be able to do this. Okay, but we're a little short on time here. So we take a look at that first number. Or actually, we take a look at those first 2 questions up at the top. Okay? You'll notice it's not just an answer. Because the answer to that first one is 3 significant digits. So when doing homework questions, you might just be like, oh, well, the answer is 3. Why is it 3? What did you do to get 3? Because if you go back and look at your work, you're going to have no idea why you wrote 3. So write something down. Notice I'm saying there's no decimal point, which means I need left and right. I'm adding that layer of work behind what I'm writing. If you don't show work when trying to solve something, it is not useful for you. Okay? You need to show that work. Okay? For question number 2, they all end up coming in as significant, which I think comes out as 6. 6 sig figs. We move down to question number 3. Notice I've highlighted that we're doing addition, and I've highlighted the least precise place, the tenths place. When we go through and do the addition, we end up with 129.04 meters. Okay? Did somebody do 4?
I plugged into the calculator, but
What'd you get?
4,538.477015. But I have a question. So
Yeah.
since we're only supposed to have 3 significant figures, would you change it to 4,530?
So when we look at this, we need
Or would it just
3 significant figures because we did multiplication division. I absolutely like how you approach this. We add that layer, 3 sig figs. 1, 2, 3. Okay? So none of the rest of that is significant.
So what would we round it up? So 4540.
That 8 is larger than 5, which means I need to add 1. So here's the common answer that people tell me.
4540.
I need 4540. The 0 is not significant, but it is telling me the 454 needs to go in the appropriate places. Okay? The next one we've got up there. The last one, did someone show their calculator? Okay, I'm going to say that's a no.
Point 0.045. Wait, why?
3 sig figs, because this is a division question. The 0 is not significant. I need the 454. Okay? A couple things I want to draw your attention to. Number 1, question 3. How many sig figs do we end up with in our answer?
3.
1, 2, 3, 4, 5. If we look at our calculations, the one that dictated our answer had 3 sig figs. In addition, we can increase the number of significant figures. That's cool. We get actually more information by doing addition. What happens with subtraction? I had 4 sig figs and more than 4. My answer has
You lose sig figs.
1 significant digit. Subtraction oftentimes results in a massive loss of significant digits. Okay, this is why when we do subtraction in the lab, we try to make sure that the difference between those numbers is huge. The smaller that difference, the less information we've got. Okay? If we're only reporting one value here, what is this one value? Is it a truth?
Wait, what?
Sure.
If we go back to how we take measurements, I only have truths for all guarantees and one guess. I always have one guess. If there's only one sig fig, guess what it is?
Truth. Yeah.
It's a guess. This is a horrible calculation to run because if I now use this number anywhere else, I'm literally basing my entire analysis on a guess. That sucks as far as data goes. Okay?
Hypothesis is